They design a fix that they think will work and then talk the crew through the rigging process. Their workaround involves the ingenious use of cardboard, spacesuit hoses, stowage bags, and duct tape. Yes, it also fixes anything in space, too. Don't leave home without it. Anthropic constant 4, carbon dioxide level. Of course, such a rig is not necessary here on Earth because just the right level of carbon dioxide is maintained naturally in the Earth's atmosphere. This is another anthropic constant. If the CO2 level were higher than it is now, a runaway greenhouse effect would develop. We'd all burn up. If the level were lower than it is now, plants would not be able to maintain efficient photosynthesis. We'd all suffocate, the same fate the astronauts are trying to avoid. Thankfully, the rigged filters work and buy the crew valuable time and breathable air. Soon the time arrives to jettison the crippled surface module. As the service module falls away, the crew sees for the first time the extent of the damage. The oxygen tank explosion blew a 12 by 6 foot panel off the side of the service module, tilted the fuel cells, and damaged an antenna. Had an explosion less than half that magnitude occurred near the heat shield of the command module, it would have resulted in a catastrophic failure of the spacecraft and loss of the crew. As they approach re-entry, the crew climbs back into the command module in an attempt to power it up. This is their only hope of getting home. The LM doesn't have a heat shield. But with all 3 fuel cells dead and only battery power available, the normal CM power-up procedure will not work. Not every system can be brought online because there simply isn't enough juice in the batteries. As a result, they have to rely on a new power-up procedure that other NASA engineers and astronauts have just finished developing on the ground. To complicate matters, condensed water is now dripping from the CM's control panels, where the temperature is a frigid 38 degrees. Will the panels short? Will the necessary systems come online? This is a dangerous environment in which to apply power, but they have no choice. Despite the danger, the new power-up sequence succeeds, and the astronauts strap themselves in for re-entry. Back on Earth, the world fixates on the fate of the 3 men. News bulletins and press conferences give timely updates. Congress passes a resolution for the American people to pray, and the Pope urges the world to pray as the 3 brave Americans, in a damaged space capsule, accelerate towards the Earth's atmosphere at a tremendous speed. In a short time, they will be pulled by the Earth's gravity to a maximum velocity of nearly 25,000 miles per hour. That's almost 7 miles per second. Anthropic constant 5, gravity. The gravity that is pulling the astronauts back home is still another anthropic constant. Its strength may be terrifying, but it couldn't be any different for life to exist here on Earth. If the gravitational force were altered by 0.000000000000000000001%, our sun would not exist, and therefore neither would we. Talk about precision. As the astronauts plummet to Earth in their crippled spacecraft, no one is certain if they will survive the violent and intensely hot re-entry. Too many questions remain unanswered. Is the heat shield fully intact? Is the ship really on the right entry angle? Will the entry batteries on the CM work? Will the parachutes deploy properly? To make matters worse, there's a typhoon warning in the recovery area. In light of all of the uncertainty, the astronauts pay their respects to the ground crew just prior to the 3-minute radio blackout that accompanies re-entry. Swigert: Hey, I want to say you guys are doing real good work. Houston: So are you guys, Jack. Swigert: I know all of us here want to thank all of you guys down there for the very fine job you did. Lovell: That's affirmed, Joe. Houston: I tell you, we all had a good time doing it. Lovell: You have a good bedside manner. Houston: That's the nicest thing anybody's ever said. Houston: Okay, loss of signal in a minute. Welcome home. Swigert: Thank you. During re-entry, a C-135 aircraft is circling in the recovery area to provide the necessary communication link back to mission control. But after 3 minutes, there is no contact with the astronauts. Tension rises. Houston. Apollo 13 should be out of blackout at this time. We are standing by for any reports of ARIA, Apollo Range Instrumentation Aircraft Acquisition. Flight. Network, no ARIA contact yet? Network. Not at this time, flight. Long pause. 4 minutes since re-entry. Still no contact. No re-entry has ever taken this long. Houston. Standing by for any reports of acquisition. Pause. Finally, the aircraft receives a signal from the capsule. Houston. We got a report that ARIA-4 aircraft has acquisition of signal, but there's no confirmation yet that anyone is alive. Houston. Odyssey, Houston. Standing by. Over. To the relief of everyone, Swigert finally speaks up. Swigert. Okay, Joe. Houston. Okay, we read you, Jack. The astronauts are alive, but one last hurdle remains. 2 stages of parachutes, first the drogue and then the main, must work or all will be lost. Without successful parachute deployment, the astronauts will be obliterated as their capsule impacts the ocean at 300 miles per hour. Houston. Less than 2 minutes now till time of drogue deployment. Waiting. Houston. Report of 2 good drogues. Coming up now on main chutes. Pause. Standing by for confirmation of main chutes deploy. The main parachutes deploy as designed, and Houston gains visual contact. Houston. Odyssey, Houston. We show you on the mains. It really looks great. Finally, after 4 days of nail-biting suspense, the astronauts, mission control, and the rest of the world breathe a sigh of relief. Houston. Extremely loud applause here in mission control. Extremely loud applause as Apollo 13 on main chutes comes through loud and clear on the television display here. Splashdown occurs at 1:07 p.m. EST on April 17, 1970. The anthropic principle, the design, is in the details. When some in Mission Control began to express doubts that the astronauts would return alive, Flight Director Gene Kranz countered their pessimism with, "Gentlemen, I think this is going to be our finest hour." Indeed it was. Apollo 13 became known as a successful failure. The astronauts failed to walk on the moon, but they successfully returned to Earth despite nearly lethal conditions. Just as the crew survived against all odds through those lethal conditions, we too survive against all odds on this tiny planet called Earth. The Apollo spacecrafts, like our Earth, were designed to maintain human life in the very hostile environment of space. Since human beings can only survive in a very narrow envelope of environmental conditions, these ships must be designed with the incredible precision and thousands of components. If one small thing goes wrong, human life is in jeopardy. On Apollo 13, the one small thing that put the crew in jeopardy seems too minor to matter. Oxygen tank number 2 had been accidentally dropped 2 inches at some point prior to its installation. That mere 2-inch drop damaged the tank's thin wall and began a cascade of events that ultimately led to its explosion. Due to the interdependent nature of the components, the failure of the oxygen system led to the failure of other systems and almost to the loss of the spacecraft and crew. Think of it. That one little 2-inch drop led to all the problems the astronauts had to overcome in order to survive. It resulted in too little oxygen, water, and power, and too much carbon dioxide and navigation error. Like a small change in the spaceship, a small change in the universe would result in big problems for us as well. As we have seen, scientists have discovered that the universe, like a spacecraft, is precisely designed to create the very narrow envelope of life-supporting conditions here on Earth. Any slight deviation in any one of a number of environmental and physical factors, what we've been calling constants, would preclude us from even existing. And like the components on Apollo 13, these constants are interdependent. A small change in one might affect others, and could prevent or destroy the conditions necessary for life. The extent of the universe's fine-tuning makes the anthropic principle perhaps the most powerful argument for the existence of God. It's not that there are just a few broadly defined constants that may have resulted by chance. No, there are more than 100 very narrowly defined constants that strongly point to an intelligent designer. We've already identified 5 of them. Here are 10 more. 1. If the centrifugal force of planetary movements did not precisely balance the gravitational forces, nothing could be held in orbit around the sun. 2. If the universe had expanded at a rate 1/1,000,000th more slowly than it did, expansion would have stopped, and the universe would have collapsed on itself before any stars had formed. If it had expanded faster, then no galaxies would have formed. 3. Any of the laws of physics can be described as a function of the velocity of light, now defined to be 299,792,458 meters per second. Even a slight variation in the speed of light would alter the other constants and preclude the possibility of life on Earth. 4. If water vapor levels in the atmosphere were greater than they are now, a runaway greenhouse effect would cause temperatures to rise too high for human life. If they were less, an insufficient greenhouse effect would make the Earth too cold to support human life. 5. If Jupiter were not in its current orbit, the Earth would be bombarded with space material. Jupiter's gravitational field acts as a cosmic vacuum cleaner, attracting asteroids and comets that might otherwise strike Earth. 6. If the thickness of the Earth's crust were greater, too much oxygen would be transferred to the crust to support life. If it were thinner, volcanic and tectonic activity would make life impossible. 7. If the rotation of the Earth took longer than 24 hours, temperature differences would be too great between night and day. If the rotation period were shorter, atmospheric wind velocities would be too great. 8. The 23-degree axial tilt of the Earth is just right. If the tilt were altered slightly, surface temperatures would be too extreme on Earth. 9. If the atmospheric discharge, lightning, rate were greater, there would be too much fire destruction. If it were less, there would be too little nitrogen fixing in the soil. 10. If there were more seismic activity, much more life would be lost. If there were less, nutrients on the ocean floors and in river runoff would not be cycled back to the continents through tectonic uplift. Yes, even earthquakes are necessary to sustain life as we know it. Astrophysicist Hugh Ross has calculated the probability that these and other constants, 122 in all, would exist today for any planet in the universe by chance, i.e. without divine design. Assuming there are 10 to the 22nd power planets in the universe, a very large number, one with 22 zeros following it, his answer is shocking. 1 chance in 10 to the 138th power. That's 1 chance in 1 with 138 zeros after it. There are only 10 to the 70th power atoms in the entire universe. In fact, there is 0 chance that any planet in the universe would have the life-supporting conditions we have, unless there is an intelligent designer behind it. Nobel laureate Arno Penzias, co-discoverer of the radiation afterglow, put it this way: astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan. Cosmologist Ed Harrison uses the word proof when he considers the implications of the anthropic principle on the question of God. He writes, "Here is the cosmological proof of the existence of God, the design argument of Paley, updated and refurbished. The fine-tuning of the universe provides prima facie evidence of deistic design.